Good day, everyone. I'm Ivy Santos, and I'm here to present and discuss a topic from STEM 12 Physics 2, which is UAM. But what is UAM, or Uniformly Accelerated Motion? UAM is defined as the motion of an object traveling in a straight line with a constant acceleration. It is to understand the behavior of objects under the influence of constant forces such as gravity. Galileo Galilei made significant contributors to understanding of motion and acceleration, but he did not specifically discover the concept of uniformly accelerated motion. Instead, Galileo's work laid the groundwork for the later improvements in the understanding of motion, including the principles that underlie the UAM. His experiment with inclined plane and falling bodies in late 16th and early 17th century provide crucial insights in relationship between distance, time, and acceleration, which were essential for the later development of UAM. When solving UAM problems, we already have the given formula. These are the given formula in solving UAM. The acceleration, time, distance, and final and initial velocity. Here are problem for today, which we're going to solve. A cannon barrel is 6 meters long. The muzzle velocity of a bullet from the cannon is 305 meters per second. What is the average acceleration of the bullet through the barrel? So analyzing the problem, we're going to find the distance and the initial velocity or final velocity that is given here. So we have 6 meters long. The barrel is 6 meters long is going to be our distance, and 305 meters per second is going to be our velocity. But what is our problem, or we're going to find? What is average acceleration of the bullet through the barrel? So we're going to find the acceleration. Let's organize them all. Our given distance is equal to 6 meters. Final velocity is going to be 305 meters per second, and initial velocity is going to be 0. And our result to find is going to be acceleration is equal to x. This is the formula we're going to use. But Ivy, aren't we going to use that one? Since it is the acceleration formula, this one. Since we've analyzed earlier the given for this problem, I'm going to explain why are we not going to be, or we're not using this formula. We have final velocity and initial velocity. However, in the given problem, we don't have any given time. So we're going to use this one. Analyzing this formula, it has the final velocity, initial velocity, acceleration, and distance that is perfect for our given. So how are we going to use this and solve that? Let us solve it together. Final velocity squared is equal to initial velocity squared plus 280. As you can see, this initial velocity, we're going to transpose this one beside the final velocity. There. So, when transposing, we're going to change the sign of a unit or a number. So, it will be negative or minus initial velocity squared. We're going to put 2D on both since we need to cancel in the left side. For canceling, we need the same unit or number, upper and the lower. Since we have 2 and D at the same, up and down, we're going to cancel them together. So question, why are we not canceling in other side of the equation or formula? Since we don't have the same unit or number, we're not going to be able to cancel anything from that side. So it will be like this. And then since it is a equal signs, we're not going to change any sign for this one. So it will be acceleration is equal to final velocity squared minus initial velocity squared over 2t. Substitute the number. It is going to be 305 meters per second square minus 0 squared over 2 times 6 meters. Solving this problem, it is going to be 93,025 meters squared second squared over 12 meters. Since we have the same unit, up and down, we're going to cancel the meter. We're going to left with meter only since we cancel the m squared. And then we're going to divide 7,752.83 meter second squared. Since our aim or our goal is to have rounded digit with one decimal place only, it is going to be 0.1 meter per second square. So, what is the average acceleration of the bullet through the barrel? It is going to be acceleration is equal to 7,752.1 meter per second square. That answered the problem. And this is the end of our discussion. I hope you learned something new and you enjoy our discussion clearly. And overall, thank you for listening.